Hi everyone. In today's lesson we'll take a look at section 4-4 on definite integrals and the fundamental theorem of calculus. So the fundamental theorem of calculus tells us if a function f is continuous on a closed interval and capital F is an antiderivative of a function on that same interval, then the definite integral from a to b of f of x dx is equal to the value of the antiderivative at b minus the value of the antiderivative at a. And what's going to happen with a definite integral is you're going to get an actual number for your answer. So it's not going to be an expression with a plus c in it. And that number is the net area under a curve, or the area between your graph of your function and the x-axis. So it could turn out to be a positive number, it could turn out to be a negative number. If your graph is below the x-axis, that's when you get a negative value for your area. So taking a look at our first example here, we're taking a definite integral on the interval from 1 to 4 of 3x squared minus 2 dx. So the first thing that you want to do is take the antiderivative. So in today's lesson we won't be doing any substitution. That's going to come in the next lesson. So with the antiderivative of 3x squared, that's going to become x to the third. And then the antiderivative of the minus 2 would become minus 2x. And remember that you can check your answer by actually taking the derivative. And then the notation for this, we rewrite it. Some people just put a vertical line here to the right. I kind of tend to do a little bracket, and we're going to evaluate this from 1 to 4. So you just take these numbers that you have here and bring them over to the bracket. So what that means is that we want to do the value of this antiderivative at 4 minus the value of the antiderivative at 1. So basically you just take and plug each of these numbers in. We're going to start with the number on top, the 4. And so we're going to have 4 cubed minus 2 times 4. We'll take that quantity and then we'll subtract what we get when we plug in the 1. So we're going to subtract the quantity of 1 to the third minus 2 times 1. Okay, so just be careful with the math in here. 4 cubed is 64 minus that 8, and then we have 1 cubed is 1 minus 2. 64 minus 8 is 56, and then we're going to be subtracting a negative 1, so it turns into addition. So our final answer is 57. So the area between our function and the x-axis is 57 square units. Okay, we'll take a look at a second example here. So we're taking the definite integral on the interval from negative 3 to 2 of 4x plus 7. Okay, so first step, take the antiderivative. So we know we'd have 4x squared over 2 plus 7x. And we're going to evaluate this from negative 3 to positive 2. So let's clean that up a little bit and simplify that 4x squared over 2 into 2x squared plus the 7x, again on the interval from negative 3 to 2. Okay, start with the positive 2 on the top, and we need to do 2 times 2 squared plus 7 times 2. We're going to take that quantity and subtract what we get when we do 2 times negative 3 squared plus 7 times negative 3. Okay, let me just scoot this up a little bit. So, sorry about that. So we're going to have 8 plus 14 inside the first set of parentheses. Okay, minus, and we're going to have 18 minus 21 in the second set of parentheses. So 8 plus 14 gives us 22. We're subtracting a negative 3. That turns into addition. So positive 25 as our final answer. Okay, today in class we did a really quick trig review. Just going to start with our special right triangles. So we have 1, 1, square root of 2 for the sides of a 45, 45 right, 1 square root of 3, and I wrote 2, so let's fix that. 1 square root of 3 and positive 2 for the sides in a 30, 60 right triangle. Okay, so in here, if we're figuring out the exact values, the sine of 0 degrees is 0, cosine is 1, tangent is 0. For 30 degrees, or pi over 6, the sine is 1/2, because we've got opposite over hypotenuse. Cosine would be square root of 3 divided by 2, adjacent over hypotenuse. And tangent is opposite over adjacent, which is 1 over the square root of 3. But we rationalize that, and it turns into square root of 3 over 3. Just a tip, you might want to keep this in here, because when we go for like working with cotangent, that would be that would make it easier to find your cotangent. Okay, 45 degrees in radians is pi over 4. The sine and the cosine are both going to be equal to each other, square root of 2 over 2. And the tangent of 45 degrees is 1. 60 degrees is equal to pi over 3 radians. And remember that the sine of 30 degrees, which is 1/2, is the cosine of 60 degrees. And the cosine of 30 degrees is the sine of 60 degrees because they are complementary angles. Okay, that leaves us with a tangent, which will just be square root of 3. Okay, for 90 degrees, it's pi over 2. And you might find it helpful to think about the graph with this, but the sine of 90 degrees is just 1, cosine is 0, and that makes the tangent undefined. One other quick thing, up here on the little x-axis, in the first quadrant, all 6 trig functions are positive. In the second quadrant, sine and cosecant are positive. In the third quadrant, tangent and cotangent are positive. And in the fourth quadrant, cosine and secant are positive. Remember the saying, all students take calculus? That helps you remember whether the functions are positive and negative in each of the quadrants. Okay, so we're going to take a look at our first example where we are going to be using that trig table. So you want to keep it handy. You're going to flip back and forth between the two sides of your paper here. So we are working with the interval from pi over 6 to pi over 3. And we have the sine of theta plus cosine theta d theta. So we want to take the antiderivative first. So the antiderivative of sine theta would be minus cosine theta. And the antiderivative of cosine theta would just give us sine theta. And again, we're working from pi over 6 at the bottom to pi over 3 at the top. So we want to take and plug in the pi over 3 first. So we want to say minus cosine of pi over 3, or 60 degrees, plus sine of pi over 3. Go ahead and group that together. And from that we want to subtract the quantity of minus cosine of pi over 6 plus sine of pi over 6. Okay, so either use the special right triangles or use your trig table to help you out. The opposite, or minus cosine of pi over 3, cosine of 60 degrees, or pi over 3 radians, it's going to be 1/2, but this makes it negative 1/2. The sine of pi over 3, or the sine of 60 degrees, would be square root of 3 over 2. Okay, subtracting the quantity minus the cosine of pi over 6, that would be minus the square root of 3 over 2, plus the sine of pi over 6, that's a sine of 30 degrees, which is 1/2. Okay, so we've got negative 1/2 plus the square root of 3 over 2 minus a negative square root of 3 over 2, which is going to turn into a positive square root of 3 over 2. And then minus that 1/2 on the end. So collect all those like terms. And when we take the square root of 3 over 2 plus the square root of 3 over 2, it does give you 2 square root of 3 over 2, but that would just simplify to the square root of 3. And negative 1/2 minus 1/2 is negative 1. Final answer. You could also have rewritten your original function as sine theta minus cosine theta, and then plugged in those values for theta. Okay, in question number 4, we have some more trig here. Notice that we have a 3 out in front of the cosecant x cotangent x, so we can take that 3 and put it out in front of our integral sign completely, or just put out in front of the antiderivative here. So cosecant x cotangent x, when you take the antiderivative of that, that gives you negative cosecant. So we're going to have negative 3 cosecant x. And again, we're going to be working on this interval from pi over 2 to 3 pi over 4. Okay, as usual, just pay attention to your notation here. So relatively simple. We want to take negative 3 times the cosecant of 3 pi over 4. And then we're going to subtract negative 3 cosecant of pi over 2. Okay, keep in mind that cosecant of the angle is equal to, or negative, let's say negative 3 cosecant x would be equal to negative 3 over sine of x. Cosecant is the inverse of sine. Okay, if you find it easier to do it this way, you can factor out that negative 3. So we can have negative 3 cosecant of 3 pi over 4. And then we'd have minus cosecant of pi over 2, like that. So it might make it a little bit easier. Okay, cosecant of 3 pi over 4 would be 1 over the sine of pi over 4. And because pi over 4 and 3 pi over 4, they're both positive because sine is positive in the second quadrant, so cosecant would be positive. So 1 over the sine of pi over 4. So pi over 4, the sine of it would be square root of 2 over 2. So if you did the reciprocal, and once you simplified it, you just would end up with the square root of 2. And this is a case where you might find it easier just to work with the 45-45 right triangle. So the sine of this 45-degree angle would be 1 over the square root of 2. And it's just easier to think about the cosecant as hypotenuse over opposite, so square root of 2. Okay, from that we're going to subtract the cosecant of pi over 2. So if you take a look at the sine of pi over 2, 90 degrees, you get 1. So the cosecant is also going to be 1. So you can take and distribute. We've got negative 3 square root of 2 plus 3. Final answer. And you could also write it as 3 minus 3 square root of 2. Okay, in our fifth example here, we want to take a second and rewrite it before we take the antiderivative. So it's the definite integral from negative 1 to positive 4. And so I want to rewrite it by taking each of those terms, 3x to the 4th, divided by x squared, minus x squared over x squared, plus 4 over the x squared dx. So the antiderivative, actually simplify it first, and then we'll apply the power rule. So we'll have 3x squared minus 1 plus 4 times x to the negative 2. So rewrite it with that negative exponent, and we're finally ready to take that antiderivative. So the antiderivative of 3x squared, if you add 1 to that exponent on x, it's going to be 3x cubed, but then you have to put it over 3, so that's going to simplify to just x to the 3rd. Okay, the antiderivative of negative 1 would be negative 1x. And then the antiderivative of plus 4x to the negative 2 would become plus 4x to the negative 1 all over negative 1, because you add 1 to the exponent. So negative 2 plus 1 is negative 1. I'm going to put it in this notation, but we are going to clean it up just a little bit more before we get started. Okay, so leave the x to the third, minus x. This, because we have a positive 4, negative 1, let's rewrite it as minus 4. And we have this x to the negative 1, put that down in the denominator. So we're going from negative, on the interval negative 1 to positive 4. Let's scoot this up just a little bit. And then we're ready to plug in our numbers. So start with a 4 on top first. Okay, so we're going to do 4 to the third, minus 4 over 4. We're going to subtract from that what we get when we plug in this negative 1. So just be careful. It's negative 1 to the third minus a negative 1 minus 4 over negative 1. So lots of opportunities for minor mistakes in here. Okay, so next, just keep working on simplifying it. So 4 cubed is going to give us 64. Minus 4 minus 1. Over here we have negative 1 plus 1 plus 4. Okay, so we've got 64 minus 4 is 60, minus 1 gives us 59, minus 4 in here. So 59 minus 4 is 55. So the area between our curve and the x-axis is 55 square units. Okay, so we have one more, and then at the very end I'll give you instructions for how you can check this on the graphing calculator. Okay, so number 6, notice that the interval is set up at the bottom number is larger than the top number, from 9 to positive 4. We're going to go ahead and do it this way, but I will show you how to rewrite it if you feel better about having the 4 on the bottom and the 9 on the top. Okay, so before we take that antiderivative in here, just take a second and maybe rewrite it as x to the 1/2 plus 5 dx, and then take that antiderivative and we'll have x to the 3/2, excuse me. We would divide it by 3/2, but I'm going to go ahead and just change it. So instead of dividing by 3/2, we're going to turn that into multiplication by multiplying by 2/3. Okay, plus the 5x, and we're going to take a look at this again from 9 to 4. Okay, so we want to take and plug in the 4 first, so we're going to do 2/3 times 4 to the 3/2 plus 5 times 4. From that we want to subtract 2/3 times 9 to the 3/2 plus 5 times 9. Okay, 4 to the 3/2, well, you take the square root of 4, that's the bottom number, and you get 2 to the third is 8. So we want to take 2/3 times 8 plus 20. 5 times 4 is 20. Okay, we're going to subtract from that what we get by taking 2/3 times 9 to the 3/2. So 9 to the 3/2 is going to give us, square root of 9 is 3 to the third is 27. So 2/3 times 27. We'll simplify that in a second. And then on the end, 5 times 9 is 45. Okay, so still working on simplifying. Yeah, 16/3 plus 20 minus 18. 2/3 of 27 is 18 minus 45 on the end. When all is said and done in here, you should have negative 113 divided by 3. Okay, so let's talk about how to do this on the calculator. Just a reminder that you can use the graphing calculator to check your work only. You can't use it just to get your final answer. You won't get any credit on the upcoming test if you just were to say put a number like that down as your final answer. Okay, so for this particular one, oh, I almost forgot. I wanted to tell you how you can rewrite this. So if we take a look at it, the original was the definite integral from 9 to 4 of the square root of x plus 5 dx. Okay, we can also rewrite this and making that integral go from 4 to 9 just by putting a negative out in front. So it'd be minus and then the definite integral from 4 to 9 of the square root of x plus 5 dx, and then you would just continue on like we did the problem. Okay, well, let's say that we are trying to do this on the graphing calculator. Okay, so we're going to try this original one. So on your calculator, if you can find the math key, little key to the left hand side, and then you pull up a menu, and next to number 9 on the menu it has this little notation fn, so function, and then int. So look for that option, and you want to select it so you can scroll down and hit enter once you reach it, or you could just type the number 9 and hit enter and it'll call it up on your screen. So when you see it on your screen, you'll have fnint and then parentheses. Okay, you want to type in your function, so you're going to do square root of x, make sure you close those parentheses around the x plus 5, and then press comma, which is to the left of the parentheses key, and then type in an x. There's a key that has x comma t comma theta comma n on it. So if you just press that, you should get the x. Put another comma, put your lower boundary, which is 9, upper boundary, which is 4, and close the parentheses. Now when you do that, it's going to come back with like 37.6 repeating. If you want to turn it into this fraction that we got, the negative 113 over 3, you press the math key again, and then option number 1, you see it has like it'll take your answer. Sorry, I don't have my calculator in front of me. It'll take your answer and turn it into a fraction. So it'll be like ans arrow frac. So if you choose that, if you hit enter and then hit enter again, it'll convert this to the 113, the negative 113, excuse me, over 3 for your final answer. Again, just remember that this piece on the calculator can only be used to check your work. Okay, and so I encourage you to try that on tonight's homework assignment. If you do have any questions, please don't hesitate to send me an email or stop by before school tomorrow.